A very good evening, everyone. Welcome to day 4 of Adult Faculty Development Program on AI in Action, Bridging Theory and Practice in Data Science and Deep Learning, organized by St. Mary's College, Autonomous Thrissur. Let us begin today's proceedings with a silent prayer. Thank you, dear participants. Before we begin, a gentle reminder. Please keep your microphones muted and cameras turned off during the sessions. Kindly use the chat box for queries. A minimum of 80% attendance throughout the FDP is mandatory. Participants must secure at least 70% marks in the assessments conducted during the program. As per adult FDP rules, attendance and feedback submission are mandatory for certification. We request your cooperation for the smooth conduct of the sessions. Today, we are privileged to have two enlightening sessions on deep learning. The first session is on Introduction to Deep Learning, Theoretical Foundations and Core Concepts. And the second session focuses on Modern Deep Learning Architectures, CNN, RNN, and Transformers. Both these sessions will be handled by our eminent resource person, Dr. Venkatesan M. I invite Ms. Archana CS, Assistant Professor, Department of Computer Science and Applications, to kindly introduce our resource person. Ms. Archana, please.
Good evening, everyone. It's my privilege to introduce Dr. Venkatesan M, Associate Professor in the Department of Computer Science and Engineering at NIT Puducherry. Dr. Venkatesan obtained his PhD in Computer Science and Engineering from VIT University, specializing in spatial data mining, and holds an MTech in Information Technology and a BE in Computer Science. Over the years, he has served as lecturer, senior lecturer, and assistant professor at VIT Vellore, later at NIT Karnataka, and is now a part of NIT Puducherry, contributing actively to research and academics. His research spans AI, machine learning, data mining, image processing, geospatial analysis, blockchain, social network analysis, and generative AI. He has led prestigious funded projects including GIS-based early warning landslide susceptibility model under ISRO SACS Respond program, multigraph-based anomaly detection for social network analysis under DST ICPS. He also holds a German patent for his work titled System to Accelerate Fake News Detection Using Quantum Machine Learning. Dr. Venkatesan has authored over 70 publications in reputed journals and conferences, with significant contribution in ocean color retrieval, environmental monitoring, and hybrid machine learning algorithms. As a passionate educator and mentor, he continues to inspire students and researchers alike. Today, we are fortunate to have Dr. Venkatesan with us for two insightful sessions as part of this FDP. With his vast experience and bridging theory and real world applications, his sessions will surely enrich our understanding and spark new research ideas. Please join me in welcoming Dr. Venkatesan M to share his knowledge with us. Sir, please take over.
Thank you. So you people have unmuted me, so I am not able to speak. Hello. I'm
Sorry,
audible.
sir. Yes, you're audible now.
From the beginning onwards, I'm saying hello, but no, nobody is able to catch me. Okay.
Okay.
Right. That's good. Actually, I'm traveling. As I informed to your organizer already, the session is not able to shift it. So, but what I'm requesting that I've joined now, but I will connect my laptop after 10 minutes. Okay, once I reach home. Yeah, so the topic which is given to me is on deep learning. And also, Madam has messaged me that some basics, machine learning and AI and introduction to deep learning is covered by some speakers. So I want to know about the audience. So what do you know? What is your understanding about deep learning? Why deep learning is required? Uh, you have already have machine learning. Why deep learning is required? Anyone can unmute and speak. Or you can say, what is the difference between machine learning and deep learning? So what is happening in machine learning? When you develop a machine learning model, you have a data, and then you will have future engineering, and then you will have our machine learning model, whether it is supervised learning or unsupervised learning. Then you will get the pattern. Right? What do you mean by future engineering? The future engineering is nothing but there are two categories in the future engineering. One is future selection, another one is future extraction. What is future selection? For example, there are some 10 features X1 to X10, and you know that the X1 to X5 are important. So you'll be considering that five feature that is called as a feature selection. And feature extraction is slightly different. You have X1 to X10, there are 10 features, and from that 10 features, you will be deriving a new set of features. It may be two or it may be three. Okay, so you are trying to derive, or you can say you are trying to extract a new set of features from the existing feature. That is called as feature extraction. So, future selection is slightly different from feature extraction. This is what happening in machine learning. Earlier, you used to call it as a data pre-processing. In data pre-processing, this feature engineering is a part of it. You have called it as dimensionality reduction. Okay, you would have studied like a dimensional reduction. So in feature extraction, there are many methods. One is PCA, principal component analysis, and then LDA, linear discriminant analysis, and ICA, independent component analysis. So you have to extract the features first, and then you can apply your machine learning algorithms to develop the machine learning model. But what about deep learning?
In deep learning, not feature engineering is required.
Yeah, very good. So feature engineering is not required. Why?
We will
Features are
automatically extract
automatically
the
learned by
features.
the algorithm.
Very good. So the deep learning will learn or extract the features automatically from the given input data. Correct. So that is the one of the first difference between machine learning and deep learning. Then the second difference is in machine learning, you can train the model with limited samples. But when you go for a deep learning, you require some amount of data. So the rule of thumb says that if you want to get real good deep learning model, minimum number of sample is some 5,000 sample is required to build a good deep learning model. Okay, so these are the two important difference between machine learning and deep learning. Now, when you say deep learning, right? Why it is called deep learning?
Due to the presence of several hidden layers.
Correct. So the neural network is the base for deep learning. Am I right? So in neural network, you will be having the input layer and hidden layer and then output layer. Okay, there are three layer architecture. Let us assume like that. Now, instead of having one hidden layer, we can have many hidden layers. So why you have to have many hidden layers? The learning will be more accurate. That is the idea. So the research community decided that instead of having one layer as a hidden layer, we can have any number of hidden layers so that the learning will be more accurate. That is the ultimate aim. But when you have more layers, the complexity is getting increased. Okay, that is also there. Correct. So in deep learning, the neural network is the base, right? You can say that deep neural network. Then when you say the neural network, there are there are three neural network models. I hope it is covered, but quickly I will tell you. The first neural network model introduced in the year of 1943 by McCulloch and Pitts. Okay, there are two people. They have published a paper in 1943 which talks about the MP neuron model for logical gates. Okay, so that is the first ANN. You can say that artificial neural network model introduced by MP, that is McCulloch and Pitts, which is shortly called as MP neuron model, and then which is also called as single layer threshold unit architecture, right? So what we used to do in a neural network, we'll have the inputs, and then no, once the input comes to the neuron, and then it will pass that inputs to the next neuron, so that link, that is the edge, or you can say the connection, or you can say the synapses between one neuron to the another neuron, okay, always associated with the weights. Okay, so the when you compute the net input at the output unit neuron, it will be nothing but the sum is equal to summation of I is equal to 1 to n xi wi, right? So xi is the input, and wi is the weight associated with the each input, right? So then once the net input is computed, what we will do, we want to get the output. So we will sum with the threshold. Okay, the threshold will be it will be the user defined value, and we will compare with the threshold. And if it is greater than threshold, then the output will be 1. If it is less than threshold, then the output will be 0. This is what happening in MP neuron. Then the second neural network model is perceptron, okay, which is introduced by Rosenblatt in, I think, in 1958 or 59. Okay, so what is the improvement from the MP neuron? In the MP neuron, you had the sum is summation of I is it 1 to n xi wi, but this Rosenblatt introduced the equation become sum is equal to b plus summation of I is equal to 1 to n xi wi. Okay, that where the b is nothing but the bias. Okay, so the bias is the one of the parameter which is used to converge the output as 1. Okay, for that he introduced the bias, and apart from that, he laid down the base for updating rules, right? No, that is called as perceptron learning rule. What it does, which is mainly used to update the weights. Why we have to update the weights? The neural network model may produce the output, and they will be having some expected output. You will try to compute the error. The error is nothing but the expected output minus the output which is produced by your model. So the expected output is t, and output which produced by model is y. So t minus y is the error. Okay, and this error, if it is maximum, okay, the idea is you want to minimize the error. So if you want to minimize the error, what you have to do, you have to tune the model. Okay, so the tuning means nothing but you have to tune the parameters of your model. So here, in case of neural network, the weights are the parameters. The weights are the parameters. So you have to update these weights. So for that, how to update
Excuse
the
me, sir.
weights? Yes.
Sir, the screen is not visible, sir.
Huh?
The screen is not visible, sir.
That's what I said. I will be sharing my screen in another 10 minutes because I have to connect my laptop. Okay. Hello. You got my point?
Okay, sir. Okay.
Okay.
Uh, okay. I will be connecting my big laptop after 10 minutes. Then I will show you the all the informations. Okay. So just I'm recalling the neural network model which is covered by somebody. Okay. So this the Rosenblatt introduced perceptron learning rule. It mainly used to update the weights. Okay. So you know that that equation is nothing but the new weight is equal to old weight plus modified weight. Okay. But what is the modified weight? The modified weight is nothing but delta, or you can say theta, then the modified weight, then the error, and then the input I. Okay, so the modified weight will be the eta learning rate multiplied with error, which we computed E, multiplied with the input I. That will be the modified weight. So if you substitute in this equation, that is new weight is equal to old weight plus modified weight, you will get a new weight. Like that, we have to update the bias also. So this is the contribution of Rosenblatt, that is nothing but the perceptron neural network model, where he introduced two concepts. One is the bias and another one is the perceptron learning group. Then there is a third model in the neural network. It's called as backpropagation neural network model. I hope it is also covered. Is it covered? Backpropagation?
Yes, sir.
Whether the
Yes, sir. Covered.
backpropagation, it's covered. So what is backpropagation? Then tell me, what is backpropagation? You will compute the error, okay, and then the error will be, there are two-step process like forward process and backward pass, correct? So in forward pass, what you will do? You will supply the input and wait, you will compute the output, and then based on the output, you will compute the error. In that backward pass, you will propagate this error back to the network, and with the help of that error, you will try to update the weights. Okay, this is what happening in backpropagation neural network, right? So these are the three important neural network model everyone must know before understanding the deep learning. Now then, as I said, this deep neural network is further divided into two, CNN and RNN in deep learning. Okay, we have convolutional neural network and then recurrent neural network, right? So any idea about CNN? Convolutional neural
It's a
network.
convolutional neural network.
Okay, what is the purpose of it?
We are basically using it for classification.
Okay, what else?
The inherent features are
Image classification.
Image and pattern recognition.
Image and pattern recognition, very good. What else? So you can classify the image, you can detect the object present in the image, you can do the segmentations. There are many things you can do by using CNN. So simply speaking, CNN is mainly useful for to deal with images. Am I right? So whenever you want to deal with images, always we can go for a CNN. Right? And what about RNN?
So time series data.
So it is a recurrent neural network. It is mainly useful to handle sequence data. As one madam said, you can deal with time series data. Okay, so I reached home. Just be on the line. Just give me 5 minutes. I will connect my laptop. Okay, thank you.
dear participants. We have shared a PDF named Reflection Journal in the WhatsApp group. Please fill this document. It is to be submitted on the last day, Saturday, before completing the FDP. Reflection Journal annexure PDF. It is shared in the WhatsApp group. Please be prepared and you have to submit it before leaving the meet on Saturday. Thank you.
Okay, so what I have shown to you, now I will show my PPT. You can see, I will share my PPT. Yeah. So as we discussed, just I given a brief. Okay. So I have given you the brief overview about the neural network models, because for the neural network is the base. Not only it's base for deep learning. Now people are talking about generative AI. The generative AI also, the backbone of generative AI is large language model. The backbone of large language model is a transformer. The backbone of transformer is RNN. The RNN backbone is neural network. Okay, so once if you know the neural network properly, then only we can know able to understand all this deep learning, the basic deep learning and advanced deep learning concept, right? So here, this slide shows the history behind this deep learning. You can see, as I said, the first the ANN model got introduced in the year of 1943 by McCulloch-Pitts. Okay, and then the perceptron got introduced by Rosenblatt in the year of 1957. And then you had a problem of XR problem. It means that by using McCulloch-Pitts and Rosenblatt, you can able to implement our computer gates like logical gates and or not, but you are not able to succeed with the XR gate. Okay, then you move to the multi-layer architecture. That's why you got this backpropagation. Okay, and as I said, the Rosenblatt, anyway, I will show you that slide also. Okay, so these are the three important neural network model, right? Then in the year of 1998, you got this CNN, the Lee Chen. Lee Chen is a guy. He introduced the first CNN model. It's called LeeNet model, which is mainly useful for, you can see in the down, for to recognize the digits. I know you will be having some hands-on how to recognize the digits by using a deep learning model using Altair AI Studio. That also I will show you. Okay, so the CNN model, right? It's mainly useful for image recognition, or you can say pattern recognition, right? Then later on, a lot of model got introduced, and then the AlexNet is the another CNN model. Okay, right? And then they have Google Net. There are many pre-trained model we have. Then the Ian Goodfellow, you know that deep learning book is written by Ian Goodfellow. Sorry, he invented the concept of GAN, generative adversarial network. These are some of the advanced deep learning models. Then autoencoders, variational autoencoders, and so on. Then you got in 2007, there is a very important, the important concept introduced, that is called as transformer. Because the transformer laid the base for generative AI actually, right? So people initially they use the transformer to generate the content, text mainly. Then later on, people introduce vision transformer. Like now, you are able to generate images, and there are a lot of models. Not only transformer, there are GAN, and then DZ GAN, variational autoencoder, and the flow model, diffusion model. Okay, these are some of the advanced deep learning model. Actually speaking, these models are the base for the generative AI. For example, if you take diffusion model, the diffusion model is mainly used to generate video, generate audio, generate images, and so on. Okay, so what I am trying to say here, the advanced deep learning models are helping, okay, helping to generate the content in generative AI. That's what, no, after the introduction of transformer, then you got GPT-3 in the year of 2020. Then you have ChatGPT in 2022. Then you know that the year from 2022 end to till now, many things happened, right? The OpenAI released GPT-3, 4, 5 now, right? And then Llama models, okay? So there are many generative models and Google Gemini. Now the Google Gemini AI is playing crucial role now. Now you might have noticed that the nano banana model, like everybody is now keeping in status, creating images. So many things are happening now. New inventions are coming in generative AI. So what is the backbone of this generative AI? Your deep learning models. Okay. So that's why the deep learning is very important. And quickly, this is the, since I'm very sorry for that, I'm not able to show you at the time PPT because I was traveling. So now this is the paper, 1943. This is the paper released by McCulloch-Pitts, right? And where they have proposed a simple neuron model that's called as MP neuron model. Okay, this is what I have explained. It is also called as single layer threshold unit. This is also called as single layer threshold unit. You will try to compute the net input, and then you will compare with the threshold. And then if the sum is greater than threshold, you will get some output. If it is less than threshold, the output will be 0. This is what proposed by McCulloch-Pitts.
And based on that, the first ANN got developed. Okay, so this is what I have written. I have represented in diagram the first ANN model, and we can implement the MP neuron models by using all the gates, logical gates. So this is the one this slide which talks about the implementation of AND gate using MP neuron. So these are something which are already covered. So I will skip this. And then the second model is the perceptron. The second model is the perceptron. There are three things here actually. You have to notice. One is what Rosenblatt did. He introduced a additional parameter called bias. Okay, so that's why in earlier the equation is net input y is only summation of I is equal to 1 to n xi wa, but now he added the bias. Okay, so the yn is bias plus the net input. Okay, and so bias is a measure of how easy it is to get the perceptron to output 1. That is the idea. Okay, to convergence you are added. And also he introduced the another important rule called perceptron learning rule. That's what I said. W of I plus 1, that is, we are trying to compute the new weight. The new weight is nothing but the old weight plus modified weight. What is this modified weight? Delta W. Delta W, that modified weight is nothing but eta. Eta is the learning rate multiplied with error. What is the error? Error is nothing but the target output T minus Y. Y is the output which is produced by your model. And then I is the input. Okay. So it's not only updating the weights, you have to update the bias also. So the new bias of I plus 1 is equal to old bias plus the learning rate eta, then E. Okay, right? So he introduced perceptron learning rule to update the weights. And then what is the use of this model? This outcome of this model is he introduced linear separability. Okay, so that is what the perceptron convergence theorem states, that for any data set which is linearly separable, the perceptron learning rule is guaranteed to find a solution in finite number of steps. Okay, so what is linear separability? There are some set of points belongs to positive class. There are some set of points belongs to negative classes. You want to separate it. You want to discriminate it. Okay, so by using, you can see here, by using a line, it is called as linear separable line or decision support line. By using this, you can separate the two set of points belongs to positive class and negative classes. Okay, right? And then the third model, and another problem is you are not able to see. You can able to implement AND gate, OR gate, and NOT gate by using McCulloch pits like per C. These are what is AND gate? When both the inputs are 1, then output is 1, right? So this is a 1 point, and all the remaining points are other classes. So you are able to separate these two set of classes by using a addition boundary line. Okay, like that OR gate also. But what about XOR gate? You are not able to separate it. See here, if you have a line here, you are not able to separate white point and black point. And if you have a line here, you are not able to separate it. So what is the solution? Instead of having single layer threshold unit, let us go for 2-layer unit one. That's how they have introduced this perceptron. And also the output functions should be differentiable output functions. Okay, that's why instead of having threshold, we have replaced with differentiable output function, so that one of the differentiable nonlinear output function is the sigmoidal function. Okay, 1 divided by 1 plus e power minus x. Okay, so we will compute the net input and you will apply the activation functions on the net input to get the output. Okay, so that activation function you would have studied while studying neural network. There are many activation functions: sigmoidal activation functions, binary sigmoidal activation functions, bipolar sigmoidal activation functions, tanh functions, ReLU functions. There are different types of ReLU functions you would have studied. Okay, so I don't want to enter into that, but the idea is you want to have the nonlinear differentiable output function. Okay, and then in backpropagation, another important concept is gradient descent. Any idea about gradient descent? What is use of gradient descent? Since you people have studied neural network, tell me. Anyone?
Sir,
Yes.
gradient descent is used to minimize error.
To minimize error? Yes, Surya madam. Yes, you are correct. Gradient descent is used to minimize the error. You can see here, but to minimize the error, you can say to minimize the error or to minimize the loss function, right? So the main thing is it determines the weight vector that is used to reduce the error. Now, this is a graph which is drawn here. Error with respect to weight in y-axis and x-axis we have the weight. Okay. Now first you have weight 1. You can see weight 0. Okay. And you are seeing the error. What is the error? And this is the error. And still you want to reduce. So you are moving towards the descent. Okay. Okay. You are moving towards the steepest descent. That's why it's called gradient descent. The next weight. See W1. Now the error is bit reduced. Then next weight. Weight 2. Further the error is got reduced. Then final. Weight 3. The error is very minimum. So now while considering W0, the error is different value. W1 further the error is reduced. When you consider W2, the error is further reduced. When weight 3 is considered, the error further reduced. Okay. So it means that to find the optimal weight to reduce the error, that is called as gradient descent. So the purpose of gradient descent is to determine the weight vector which reduces your loss function, or you can say which reduces error. Clear? For that purpose, you are using gradient descent. Why I am telling this? In deep learning, the gradient descent is very, very important. Okay. And backpropagation, you know that there are different type of gradient descent: stochastic gradient descent, batch gradient descent. Okay, there are many categories. Which gradient descent is used in backpropagation? Any idea? Stochastic gradient descent is used in backpropagation algorithm. Right? Stochastic gradient descent is used in backpropagation algorithm. I don't know whether they have taught about derivation rules in the backpropagation. Whether they covered how to derive
Yes,
this.
sir. Yesterday we had a short description about this chaining rule.
Derivative rules. How to get the gradient
Yes, sir.
descent derivative. Okay, then
During the
it's fine.
backpropagation.
Okay, then it's fine. So when you want to learn this backpropagation, you must know 3 things. One is gradient descent that you discussed. Second one is a chain rule. Okay, because you have to update the intermediate weights, so you need a chain rule. And then you need a dynamic programming, which is called as memoization. What it does, it's nothing but it's storing the computation in the cache. It's storing the computation in the cache. So by using that, so that it will it will perform the computation very faster. That is the importance of the memoization, right? So these are the 3 key institutions required for backpropagation. Okay. So and backpropagation is already discussed by somebody, like you have forward step and backward step, which I also discussed. Okay, recently. So forward step, we will give the input and then we will compute the output. And backward step, we will backpropagate the error to the previous layers. Okay. So this is already explained, I think. So I'm not going to touch upon that. So this is a backpropagation algorithm. Okay. I hope it is also explained. Now, as I said, in backpropagation, stochastic gradient descent is used. Okay. So it means that for each example, you will compute the error. For each sample, you will compute the error, and then you will compute the error, and then you will backpropagate the error. Okay, this is what happening, and these are the 2 equations. One is the error at the output layer, another one is the error at the hidden layer, right? Okay, now we will go to the deep learning. 1 minute, I will share you the slide. So according to me, I used to divide this deep learning into part 1 and part 2. Okay, I used to divide the deep learning into part 1 and part 2. So I will divide like this. Part 1 is, or what I will do, stuff here. Are you able to see my Word document?
Yes, sir.
So I used to divide the deep learning into part 1. In part 1, you will have the neural network basics. Okay. Because without knowing neural network, there is no meaning of understanding deep learning. And then you will have regularization. Regularization. EG, I'm sorry. And then we'll have optimization. This is the part 1. Part 2, where the deep neural network is further divided into CNN and RNN. Okay. So further, we will learn what is CNN. In CNN, you must know CNN architecture. Okay. So when you learn CNN architecture, then you must know what is convolution operation. Okay, convolution operations, and you must know pooling. Okay, and there are different type of pooling, like you have minimum pooling, maximum pooling, average pooling, and so on. That I will explain to you. And you must know the relationship between the input and output. Okay, input and output. All these things you must know. And then the CNN applications you must know. CNN applications is used for object classification, and it's used for object deduction. Okay, and segmentation. Sorry, segmentation. Okay. Then when you come to RNN, so as I said, the CNN mainly used for to process the images, and RNN is mainly used to handle sequence data. So when you say sequence data, it may be like predicting stock price or predicting gold rate, and predicting the DNA sequence, okay, or any time series data. You can use this RNN. And there are different category of RNN. You would have heard about it, LSTM. Okay, and then you have GRE, and there are many like BERT model. Okay, and then you have the recent one, transformer. Okay, right. So this is the complete overview of deep learning course. Okay, when anyone is studying deep learning, so you must know the part 1 first, the neural network basics and regularization and optimization. Then part 2 is deep neural network, where you have CNN and RNN. So you must know how to build a CNN architecture. Okay, and then recurrent neural network. Right. Now, as per my time limit, I will try to cover maximum. Okay, right. So I will come to this regulation optimization. So I will quickly touch upon the CNN. So, okay, quickly we'll have a quick, because since we have already covered neural basics, and I will touch upon what is regularization and optimization. Any idea about regularization? What is the need of regularization? What is the need to have regularization? Anyone? You can unmute and speak, please.
So to solve overfitting,
Very good. Very good. What is overfitting?
when the model works well on training data set but doesn't work well with testing data set, it is said to be overfitting.
Okay. Exactly. So you will be having data, and when you train the model with the training data, it may give you the good accuracy. So training accuracy will be good. For example, the training accuracy is 90%, and the same model, when you work with the testing data, it may give you some 60%. Okay, so it means that it works well with the training data, but it is not working well with the testing data. That's called as overfitting. Okay, so the regularization is required to handle this overfitting. It means that you need some generalized model. You don't want a overfitted model and underfitted model. Okay, what is underfitting?
The algorithm is not able to learn the model correctly, maybe due to the lack of data or maybe due to the inefficiency of the algorithm.
Very good, madam. So, as she said, even it is not able to work well with the training data itself. Okay, it's not able to learn the patterns. That's called as underfitting. So, what you can do, you don't want an overfitting model, you don't want an underfitting model, you want to have generalized model. Okay, so for that only people have used regularization. It is used in machine learning and it is used in deep learning. So there are different type of regularization techniques are available. One is the leasehold regularization. It's called as a loan regularization. Then second one is called as a reach regularization, which is called as L2 regularization. And then there is a third one, which is called as elastic net regularization. It is nothing but hybrid model, combining L1 with L2. And apart from this regularization, there are some more regularization techniques are available. Dropout. Okay, so this is what you used to do in deep learning actually. You would have seen some dropout layers when you build your CNN models. So what is a dropout? You may feel that some connections are not important. You will make that weight as 0. Okay, that is called as dropout. So you can say randomly assign weight element as 0 during training. Then ensemble models, you may use some models to get the accuracy, but a single model is not capable to produce the output. Then in that case, what you will do, you will integrate a model 1 and model 2, and then you will take average prediction of the model. Okay, by using soft voting and hard voting. There are different type of ensembling, like you have boosting, and you have bagging, and you have stacking. These are the three ensemble models are used. And then early stopping. Any idea about early stopping? Any guess?
So when the desired output is not achieved even after subsequent epochs, stop it.
It means that, see, what you used to do in neural network backpropagation, first you will compute the error and you will backpropagate, you will update the weights. Okay, then once again you will compute the error, correct? The second iteration. Still, you feel that the error is high, then you will try to minimize the error. So you will once again you will use gradient descent and you will update the weights. So like that, you will keep on used to do. That is called as epoch. Okay, epoch 1, epoch 2, epoch 3, and so on. Let us assume that epoch 10, you got some accuracies, some 90. And then even if you do some another 10 epoch, the same accuracy is coming, then what is the need to train? You can stop it. Okay, you can stop when there is no improvement in your validation set error, then you can stop it. That is called as early stopping. And then there is a one more technique called as regularization. What is that? Data augmentation. What do you mean by data augmentation? Mainly, it's mainly very useful for deep learning. Any idea about data augmentation?
When we have a lack of data, maybe we will want to increase the size of the data either by doing some geometric transformations, or maybe we want to rotate the data, rescale it, or some kind of transformations to increase the data size for the training purpose.
Very good, madam. Very good. So you are correct. So as you said, it is mainly like when you have lack of data, because I said minimum you require some 5,000 samples. When you do many applications like power crop, disease prediction, and so on, sometimes you may not get, you may get less samples. Okay. So then what you can do, so first let us assume that you have some 2,000 samples. but you need some 5,000 samples to get a good model. Then what you can do, you can rescale the images, right? You can rescale the images, and you rotate the images, you flip the images. Okay, so that is called as a data augmentation. So mainly it is increasing the small amount of data to the large amount of data, okay, for some extension. Okay, that is called as data augmentation. So these are some of the important regularization techniques we have to use in machine learning as well as in deep learning. Okay. So this is what you discussed, regulation overfitting and underfitting. Okay. And so in machine learning, this I hope you would have heard about this bias variance trade-off, correct? What is bias and variance? Bias is the there are some, for example, it is look like small error, okay, due to wrong assumptions about the data. Then it's called as a bias. And variance is nothing but the data is too sensitive to the any variations in the data. That is called as variance. These are the two standard measure used for bias and variance trade-off. So in the bias and variance trade-off, I will skip this, and we can see. So high bias and low variance. A model with high bias and low variance is said to be underfitting, and high variance and low bias is called as overfitting. We can see here. So this is the famous example to explain the bias and variance, and this is the dot examples. When you are throwing a dot on the board, okay, so this is the exact area where you're supposed to throw, but you are thrown somewhere. So the distance, okay, the distance between this is the error. That is a bias. The bias is high here. Okay, but what about the spread of the data? But we are thrown in some direction, but all the points are near to that. So there is no spread here. So that's why it is low variance, high bias and low variance. But what about this? Okay, you can see the same high bias because it is very far away from the actual point. But we can see there are a lot of spread. So it's called as high variance. So high bias and high variance. Okay, and then we have here, you can see now we have thrown all the points exactly. So the bias error is less. Okay, so that's why it's called as low bias, and there is no spread on the data. So that's why it is low variance. Okay, but what about this? Okay, it is somehow it is near to this point, so low bias, but the spread is more, then it is called as high variance. Okay, so when you have the high bias and low variance, it is underfitting. When you have a high variance and low bias, it is overfitting. Okay, you need a model which has the low bias and low variance. Okay, so there is a diagram, I hope, yeah. And this is called as bias variance trade-off. You can see this side. Okay, this is the training data. So where normally when the model is simple, okay, the one more concept you must know, when the model is simple, always the bias will be high. Okay, you can see here, this is a bias, training data bias. When the model is simple, the degree of polynomial is 1, it has high bias. When the model complexity is increasing, okay, when the model complexity is increasing from degree 1 to degree 4 or 5, automatically the bias, high bias, become low bias. Okay, right? And then what about testing data? In testing data, now this point is variance. Okay, when the model is more complex, always the variance will be high. Okay, so what you don't want high bias model, you don't want high variance model. You want a model where the bias should be low and the variance should be low. So this is called as a sweet spot. Okay, this is called a sweet spot. How you are able to achieve the sweet spot? By using a parameter called regularization parameter. Okay, so that's why the equation will be adding the extra element with the training error plus omega. Okay, that omega is nothing but the it's called as a regularization parameter. Okay, so you want to get this sweet spot, that is called as a bias and variance trade-off. So this is what happening in regularization. So other things you can explore it. Okay, so that's all about regularization. Actually, there are many things to discuss, but I don't know whether the time will eat. So I'll skip on that. And then you must know parameter and hyperparameter. Any idea about what is parameter, what is hyperparameter?
So hyperparameters are like kernel size and stride and all, and parameters are like weights.
Yeah, that I know. Any other? You are correct only. If the parameters are internal to the model, okay, like which is not fixed by the user, then it is called as a parameter. Okay, like the coefficients of the linear regressions and weight and bias in the neural network, then cluster centroids in the clustering. These are the parameters. And what about the hyperparameters, which is fixed by the explicitly defined by the user? Okay, parameters are not explicitly defined by the user, which is pertain to the model, which is internal things to the model. Okay, so weights, bias, all these things are the parameters. But what are the hyperparameters? Which is explicitly defined by the users. For example, you can see train and test split ratio, learning rate in optimization algorithm in the gradient design, choice of automation algorithm, choice of activation functions, the number of hidden layers in linear network, the number of activation units in each layer. All these things comes under hyperparameter. Okay. Okay. Right. So optimization. So optimization in deep learning models. Okay. So as I said, gradient descent. Okay, the gradient descent is a first order iterative optimization algorithm for finding local minimum of a differential function. So by using that, you want to find the optimal way to reduce the error. Okay, for that, you are using this gradient descent. Okay, so it mathematically speaking, it uses the derivative, or you can say gradient, to gradually decrease its value. Okay, that's why it is called as gradient descent. Okay, as I said, there are different type of gradient descent. One is the batch gradient descent. Okay, so you can see here. So which is mainly used to parameter update. Okay, and then the second one is the stochastic gradient descent. So one is the batch gradient descent, where you will take a batch of group of data. Okay, where you will take group of data to find the error. Okay, but in case of stochastic, for each sample, you will do that. We'll try to compute the gradient descent for each sample. And then you have mini batch. Okay, you will take a small group and then you will try to grade gradient descent. So there are different category. We have batch gradient descent, stochastic gradient descent, and min batch gradient descent. Each one you have to discuss with detailed mathematical derivations. Okay, so please explore it on your own. Okay, let me know if you have any doubt. I will explain later. Okay, right. Now we'll move to CNN. Okay, we'll move to CNN. And so you know that what is happening in deep learning, the model extract the features layer by layer. The model extract the features layer by layer. You can see here there is a one image, okay, an input image which is given, and then you are trying to learn some edge features in one level, then texture features in another level, okay, then another features in another level. Okay, and then you will integrate it, and then you are able to classify the images. This is what happening in deep learning. So the deep learning learns the features layer by layer. Okay, low level features, middle level features, high level features. At the end, it will be combined, and then it will determine which part it is. Okay, right? Then we will combine all the parts. We will get the original image. This is what happening in deep learning, right? So that's why in convolution, CNN models, you would have noticed that maybe a sequence of convolution layer is used because it extracts the features layer by layer. Okay, so you can say that hierarchical learning is happening in CNN. Simply, you can say the hierarchical learning is happening in CNN, right? So, what is CNN? Basically, if you look the CNN models, or forget about CNN, there are two mathematical operations are available to extract features from the images. One is the convolution and second one is the correlation. Okay. So by using these two operations, always you can extract the information from the images. Now in convolution layer, we are following this convolution operations. Okay, we are following this convolution operations to extract the input from the images, right? So here you can see this is the input, and we have a filter. You can call it as a filter, or you can call it as a kernel. And this filter or kernel will be applied. Okay, it will be slide over on the image, and then you will get the output. This output is called as an activation map. Okay, this output is called as an activation map. Anyway, I'll be explaining very detailed in the forthcoming diagrams. So what is convolution layer? Convolution layer is the core building block of CNN. The parameter consists of set of learnable filters, and every filter is small spatially, where you will have width and height, but extends through the full depth of the input volume. I will explain that. What is the, it means that no, the input data will have some height and width and depth, and as well as the filters, that is kernels, will also have the height and width and the depth. Okay.
So
So
what will be the
yes,
impact if you're going to apply correlation instead of convolution here?
no, correlation is a different mathematical formula, and convolution is a
Actually,
different.
both operations are same. Just we need to flip the filter by 180-degree, right?
Correct. That you
So
can do. That's
what will be the impact on feature extraction?
No, see convolutions. What is happening here in convolution? Will be using this dot product, and then you will extract the features.
Yes.
Correct. There will not be much difference. We can use any one, but in CNN they mostly use the convolutions. Okay. So what is happening here during the forward pass? You will slide the convol, or you can say that sliding is called as convol. That's why it's called as convolution. Okay. So you slide each filter across the width and height of the input volume, and compute dot products between the entries for the filter and the input at any position. Okay, so the output will be like two-dimensional activation maps. I will show you here, and you can able to understand. Now you can see what is happening here. This is the input image of size 32 cross 32 cross 3. What is 3? 32 is height and that is width. What about these 3?
Number of channels.
A number of channels. So when it is RGB, how many channels will get there?
3.
3. Okay, so that's why it is called 32 cross 32 cross 3. Suppose if it is grayscale,
And then one channel only.
there will be only one channel. Okay, so then we will apply this convolutions filter on this input image. That means you will convolve, you will slide the filter on the image, and then you will get the activation map. How this 32 become 28? Any idea? I now see I applied 5 cross 5 filter, okay, on 32 cross 32. I got 28 cross 28 1. Any idea? Anyone?
Sir, if we are using stride 1, then definitely it will reduce the dimension because it has some formula, like if you have an image of n cross n dimension and stride 1 and filter size f cross f, then n minus f plus 1 by s.
Very good, very good. Okay, so you know that. I don't know about others. So yes, what's your good name?
So Dr. Ankita
From which college?
from BHU, Banaras Hindu University.
Okay, very good. So that's what I'm going to explain. So she said that the relationship between the input and then the padding. There are many things you must know, like you must know padding, you must know stride, and then you must know what is the spatial extent, and based on that we can able to compute what is the size of the activation map. Okay, anyway, I'll come to that. Just wait for some time. Right. So the idea of in convolution is just we'll slide this filter on the input image, and then you'll get the activation map. Okay. And the question is, it's not like you have to apply only one filter. We can apply any number of filters. Okay, you can apply any number of filters. So if you apply 2 filters, you will get 2 activation map. If you apply some 6 filters or you will get 6 activation maps. So altogether, if you combine all this activation map, that is called as feature map. Okay, that is called as a feature map. So you can see here, this is what happening. So in CNN uses the convolutional operator for extracting data features, which allows parameter sharing, efficient to train, have less parameters than NN, neural network. Any idea why the CNN has less parameters than NN? Neural network always will have high parameter than CNN. Any idea? What is happening in neural network? What kind of connections you are following? It is dense connection, right? Fully connected layer. We used to call it as fully connected layer. It is a dense connection. What about CNN? Sparse connection. CNN has sparse connections. All the input neuron will not be connected to the next level of neurons. Okay. So it is a sparse connection. So the number of parameters is less than neural network. Okay. Right. Now, as I said, here you can see I have applied a 3x3 filter on the size 5x5. Okay. And then I am just getting the it's a convolved features when you apply this convolution filter on this input data. And this is a 6x image, and I have 2 filter, and then I'm applying filter on this input image, and you can see it will perform the dot product between the input image and then the filter. We will get the the activation map actually. So what is stride? I will come to that. Stride is nothing but we are sliding over the filter on the given image. Okay. If I say stride 1, then just one column. Okay. After the next column, the filter will be moved. See here. The next also it will move here. Okay. And the next it will move here. So that is stride 1. What about stride 2? 2 column jump. See here. Now a slide is 2. Now the filter is moved to after 2 position of the column. Right, see here. Jumping 2 columns. Okay. This is stride. And this is activation map which you got. And then second filter, we'll get some different another activation map. Okay, so altogether it's called as a feature map. It's called as a feature map. So what I am trying to say here, you will slide over the filter on the input image. You will get for each filter, you will get the activation maps. So if you combine all this activation map, then it is called as a feature map. Okay. So this is for RGB. Okay, that will be 3 channels and 3 input matrix. Okay, and then you will apply filter 1 and filter 2, and you will get the output. Okay, and this is the one complete flow of CNN, and now the input image is cat, and you want to classify whether the image is cat or dog. Okay, now what happened here? You are trying to apply the convolutions. So you are trying to extract the features from the given image in different levels. Okay. Then you are applying max pooling. I will come to that. What is max pooling? Then once again, you are applying the convolutions. Okay. And then once again, you are applying max pooling. So what is pooling? What is the use of pooling? Any idea?
For dimension reduction.
Correct. Downsampling. Correct. So you are trying to reduce the dimensions. When you apply max pooling, it tries to reduce the dimensionality. What is dimensional reduction? If you have n samples and you want to reduce it into k samples, okay, let's say n is 100 and you want to reduce it into some 20 or 30, then it is called as downsampling or dimensionality reductions, right? So normally in machine learning, you have PCA and LDE and so on. Even deep learning, the pooling is performing that action. Apart from that, we have one deep learning model called autoencoder. Okay, the main purpose of autoencoder is to perform the dimensionality reduction. So here the max pooling is used to reduce the dimensionality. Okay, and there are different type of poolings, like you have max pooling, min pooling, and average pooling. You can make use of any one of the pooling. At the end, the output will be flattened. It means that it will be converted into one-dimensional vector, and then how in the final the output layer will be having this fully connected feed-forward neural network. Okay, by using that, you can able to classify it. So suppose the output is there are two objects, then you will have two neurons on the final layer. Okay, so one is for cat, another is for dog. Like that it goes on. Okay, now I will explain this. What is pooling and other things. The max pooling is nothing but, as I said, pooling is mainly used to downsample, or you can say for dimensional reductions. Now in max pooling also we'll be applying some filter on the feature map which you got after the convolutions. Now let us assume that the down, which is shown as the feature map which you got, like now in the previous diagram, first you will have the image and you will apply a convolution. So what will be the output of convolution? It will be feature map, right? Then on that feature map you are going to apply this max pooling. Okay, so max pooling also will apply one filter on this the feature map. Let me assume that I am going to apply this filter 1 on this feature map. Okay, and so first I will apply this filter 1, okay, on this input features. So the max pooling is nothing but, see, this is the filter 2x2 filter I applied here, and what is the maximum value here? 3. Okay, that will be the output. Then the second one, -3, -1, 0, and -3, which one is maximum? 0 is the maximum. Okay, and the third 3 is the maximum, and then the next one is the +1 is the maximum. Okay, like that it goes on. This is for filter 2. Okay, you can see this is called as a max pooling. So Y pooling, which is subsampling pixels, will not change the object. Like, see, this is the same word, you are applying pooling, and then you are getting just you are reducing the dimensionality. Okay, this is what happening in pooling. And there are different type of poolings. You have max pooling, and then min pooling, and then average pooling. Max pooling is nothing but you have taken maximum value, and min pooling is will take minimum value, and then average pooling is just will take average values. Right? That is what happening. So in max pooling, what is happening here? You are applying the 6x6 image, and then when you apply the convolutions, you will get the activation maps. Now the activation maps is sizes. See here what is happening. You are getting this feature map. You can see here. You are getting this feature map, but then if you after applying this max pooling, it's got reduced, right? So this is what it is shown here. You have convolutions and then max pooling. You will get a 2x2. 6x image is converted into 2x2 image. So the size of the image is reduced. Okay, right? So new image, but smaller, right? Then the first one is done. Then so this is a new image you got after this first iterations. Then what you can do on this new image, a small image. Okay, you are going to apply the next same iterations like convolutions and max. Okay, right? Then so what will happen here? Here also you'll get another further the image is reduced. You will get another new image here. Okay, then it will be converted to be flattened. It means that it will be converted as a one-dimensional vector, and that will be given as an input to your fully connected layer, which is used for classification. This is what happening in old CNN, generally speaking. So the two important operations you are doing, one is the convolutions, which you are using extracting the features layer by layer, and then you are using pooling, where you are trying to reduce the dimensionality. This is what you are trying to do in CNN. Okay, and then you will flattening. This is a flattening. So here I have shown here the new image. The new image will be in this like this, and then you will flatten into a one-dimensional vector, and that will be given as the input to the fully connected feed-forward network for the classification. Okay, so Where it is used, the CNN is used for computer vision, like classification of the images, whether it is a cat or dog, and then even it is classification and also localizing the object in the given image. That is also possible, and you can detect the object, whether it is a cat or a dog, okay, or whether any vehicle is there in the given image. So you want to detect the objects, how many objects are there in the image. So object detection, it is possible. And then we have instance segmentations. Okay, segmentation is another important concept which is mainly useful for your image processing. Okay, so you have like a deep learning model like UNet, SegNet. These are some of the models used for the image segmentations. Okay, and see, even it is used in speech recognition. Like what happens in speech recognition, will be having the signals. That signals is converted into spectrogram. Okay, that frequency with respect to time, it is converted as a spectrogram. It will be an image. The spectrogram will be considered as image, and then it will be given as input to CNN, and then you are able to recognize the speech. Okay, right. Now I will show you what is the relation between the input and output parameters. That is very important when you want to build your CNN model. 1 minute. So this is what we're applying. You have the input image, and we'll have a kernel. Okay, and we'll get the dot product between these two. We'll get the output like this. Okay. Now, so as I said, it's a small kernel, right? You will slide over on the image, and we'll get the pixel value here. So if you slide over, you'll get another feature. You'll get a slide over, and you'll get another feature like that goes on. So at the end, we'll get, this is called as a feature map. Okay. So in the case of 1D case, we slide one-dimensional filter over a one-dimensional input, right? Clear? In case of 2D, we'll slide two-dimensional filter over a two-dimensional output. So the previous one is one-dimensional, and this is the two-dimensional. What about the 3D? Okay. So 3D, this is a 3D input, and where you have taken RGB. You know that in RGB images will be having red, green, and blue, 3 channels. So there will be a filter. If you will be applying, you can see that we're trying to apply the filter on this 3D input, and what will be the output? The output when you slide over this filter, will get the output. Okay, you can see here. So you will get and height and width. Okay, so the output will be 2 dimensionals. There is no depth. Okay, but if you apply multiple filters, then you will get multiple feature maps. Then, and in that case, the output will be the volume. I will show you that. We will get to understand. So see here, this is very important that Madam from Banaras Hindu University, she has clearly said n minus f plus p divided by s, right? But there are different way to represent the formula. Now we will discuss the how to compute the width and height and depth of the new image, that is the feature map size. Okay, by applying the filter on the given input image. Now let us have the input image where which has height is 1 h1 and with this w1 and the depth is d1, and we'll come to the slide later. Now we would like to apply filter 1, so we'll get, you know that as I said, if you apply filter 1, you will get first feature map. Sorry, it's called as activation map. Then the next filter, the next activation map, the next filter, you will get next activation maps. So combined together, okay, if you apply multiple filters, what happens? Then the output will also a volume. Okay, where you can see H2 and W2 and D2. Right? Clear? So, and also you must know, like stride and padding. So I'll come to that. You know, already stride I told. Stride is nothing but moving of filter with respect to one column. See here, a stride is 1, just filter is moving with respect to only one column. Correct? Now, when you move the filter on your input image, I want to extract this pixel value. Then if I have a filter like this, if I keep filter like this, then only I can able to extract this. Otherwise, I cannot able to extract this information. So what to do in that case? Okay. So here, without considering this stride and pad, okay, right? So now, so in general, you can say the width 2, okay, the width of the outcome is W1 minus F plus 1. Okay, W1 is the width 1 and F is the spatial extent, okay, and then plus 1. And height of the new image is H1 minus F plus 1, right? So what is happening here in this case? For example, this is the size, okay? And what is this? This is nothing but padding. Okay, what is the need of padding? As I said here, I want to extract this information. So in that case, I want to add extra 0 surrounded by this image. Okay, that's why this 0 is added here. This is called as padding. So there are two things: without padding, without stride. What is the input size and output size? With padding, and what is the output size? And with stride, what is output size? Okay, so here padding is 1. It means that you have added 0, okay, in all the corners, all the side. Okay, right? Then is it easy to slide your filter on the images so that you can get all the informations, right? You can extract all the information. So the W2 is nothing but W1 minus P plus 2P plus 1. You got it? So with the padding, and earlier you have W1 minus P plus 1 by without considering the padding, but now you are considering the padding. So W1 minus F plus 2P plus 1. That is the width 2. And H2. H2 is nothing but the new image height. It is H1 minus F plus 2P plus 1. Okay. Now, what is the third parameter? Striding. So striding is, as I said, it defines the intervals at which the filter is applied. So if S is 1, then 1 column. And then if it is 2, then it is 2 column. Here you can see it is jumping, right? It's jumping next 2 columns, like that it goes on, because stride is 2. Okay. So when you consider the striding, then the output size formula will change. Okay, the W2, the width 2 of the new image, which is produced after the filter, okay, applying this convolution on the input image, then W2 is nothing but W1 minus F plus 2P divided by S plus 1. Earlier we had W1 minus F plus 2P plus 1. So, right? W1 minus F plus 2P plus 1. Now, this equation becomes, after considering this stride, it becomes W2 is equal to W1 minus F plus 2P divided by S plus 1. And H2 is H1 minus F plus 2P divided by S plus 1. The same thing. Now, so if you apply each filter, okay, on the input image, right, we'll get the output as a volume, okay, right, because K filters will give us K such a 2D outputs, okay. So we can think of the resulting output as K into W2 and H2 volume. So what I'm trying to say, if you apply multiple filters on the input image, you will get the output as a volume that is represented as height, width, and depth. Now the question is how to compute height, width, and depth of the new image after applying the filter on the input image. Okay, by using this formula. By using this formula, we have to do it. Let us work it out. Any idea? Could you please, anyone? So what are the things? The input image is 227 cross 227 cross 3. Height is 227, width is 227, and depth is 3. And filter size is 11 cross 11 cross 3. And like that, you have 96 filters. Then when you apply this filter, you know that, right? When you apply this filter on the input image, you will get the output as a volume. So you want to know what is the height of the new image, what is the width of the new image, and then what is the depth. Compute and tell me. What is W? Okay, let us compute the height. What is the height of the input image? 227, right? So it will be, I'll substitute here. H2 I want compute. H1 is 227. Correct? Minus F. What is F? Spatial extent. That is nothing but your filter. It is 11. Plus 2P. 2 into P. What is P? P is padding. What is padding is 0 here. So it is 0. Divided by, yes, what is S? Try this 4. So it is 4. Plus 1. As per this formula. So this will be 0. And this will be 7 minus 1, 6. Okay. Then 2 minus 1, 1. 2, 1, 6 divided by 4. So this will be 54 plus 1, it is 55. So the height of the image is 55. Height also same, right? Because the formula is the same. So the width also same. It is 55. What about this D2? Depth? D2 is K. What is K? Number of filters. How many filters you had? 96. Because when you apply one filter, you will get one activation map. If you apply 96 filters, you will get 19 activation map. Okay, so with inside you have 96 activation maps. Okay, got it? Now, so I explained this. Now, could you please try this? This is what is there. Now, could you please try this second one? What is second one? 32 cross 32 cross 1. And you have 5 cross 5 cross 1 is the filter size. And where stride is considered as 1 and no padding. And there are 6 filters. Tell me. What is the height? I given one example, right? People are there in the connection.
Yes.
I thought after 8, okay, so time got over, everyone just switched on and then they're doing some work. Okay, so what is the height?
Yes, sir.
And
It
width?
is 32 minus 5 plus 0 divided by 1 plus 1. So it will be 28.
28. What is D2?
6.
Okay, good. Okay, so this is how you have to complete it. Right? So the first CNN model introduced, and as I said, the properties of CNN is like in neural network you have dense connection. You can see here. This is the one example. Like you want to recognize digits. Okay, you would have heard about MNIST dataset, right? Do you know about that? It's a famous image dataset. What it is, it contains digits from 0 to 9. The digits are represented as image. Okay. Now you want to recognize these images. Okay. So when you apply neural network, you can do that. So there will be 10 classes. Okay. There will be 10 classes. Now what happens? This is called as dense connection. It's called as dense connection. Since all the neurons in the input layer are connected to the another neuron in the hidden layer. Okay. So this is called as dense connection. If you have the dense connection, the number of parameter will be more. The number of parameter, there are many dense connections. Okay. So for example, all these 16 input neurons are contributing to the completion of H11. Right. But it is contrast in case of convolution. In case of convolution, what happens? Only few local neurons participates in the computation of H1. You can see not all the neurons. In the input neurons, even though you have 16, but only few neurons are involved to compute H1. So that's why it's called as sparse connection. The connections are much sparser. It's not dense. Okay. So we are taking the advantage of the structure of the image. Okay. And this is called a sparse connectivity. What it does, since you are following these sparse connections in the CNN, okay, which reduces the number of parameters in the model. Right? Since you are following the dense connection in the neural network, the number of parameters in fully connected layer is high than the number of parameters in CNN model. Okay. Okay. Then what else I want to know? And then weight sharing is another important concept in CNN. Okay. So do you want the kernel weights to be different for different portion of the image? Okay. So, but imagine that we are trying to learn a kernel that detects the edges. We will be applying the same weight. We will not change the weight. So that's why it's called as parameter sharing. Okay. We'll be having parameter sharing in case of CNN. Right. See, we can have many such kernels, but the kernels will be, okay, these kernels will be shared by all locations in the images. So because it means that each kernel will use same weight. That's called as weight sharing. So the CNN has some properties like sparse connection, weight sharing. Okay, these are some of the important concept of CNN. Right. So I have explained what is CNN. Okay, and then I explained pooling. Now the Lechen, right? I hope you remember the first session. I've shown the deep learning history where the Lechen introduced the CNN model. Okay, that's why it is called as LeNet model, LeNet. Okay, this is the first CNN model called a LeNet. The purpose of this LeNet model, it's called as LeNet. Okay, it's called as LeNet. So this is the first CNN model which got introduced to recognize the digits. If it is characters, no, it is A to Z, right? 26 characters. And if it is digit, it is 0 to 9. So both purpose we can use. Right? And see, we have the convolution layers, right? And whether stride is 1 and spatial extent is 5 and the number of filter is 6. There is no padding. Okay, right? Like that goes on, pooling layer. But you have to compute the parameters, how many parameters required. Like I given some formula, no, based on that, you have to compute the number of parameters that you explore it. Okay, that if you have any doubt, let me know. So we have the convolution layer 1 and then we have pooling layer. Okay, and then so what you are trying to do, you will take the image, you will extract the features. Okay, you will extract the features, and then you are trying to reduce the size of the image. Okay, then once again you are trying to extract the features. Then once again you are converting you are reducing the size, and then you are flattening it. Okay, into one-dimensional vector. That will be the input to your fully connected layers. Right, you can have any full number of fully connected layers. And there is a formula to compute the parameters. Please explore it. So this is a one complete CNN model. Okay, like that, there are many CNN model. You can use it. Okay, and this is what the same, like when you apply the input and filter and max pooling, what is happening. So 1, 4, 5, 8, the maximum pooling is maximum it has taken. 7, 6, 1, 3, 7 is the maximum. 4, 5, 1, 2, 7, 5, the 5 is the maximum. Okay, you can see here. This is what happened. So as I said, LeNet for handwritten character recognition, LeNet 5. Okay, so there are many CNN model, like we have AlexNet, ZepNet, VGGNet. There are many things. Okay, so there is a competition. It's called as ImageNet Large Scale Visual Recognition Competition. There only they have introduced, the model. That's why it's called as the ILS VRC 10. Okay, then there is a computation on 11, then 12. Okay, what happens? The number of parameters is decreasing. Okay, so see here, Google Net, and then RESTnet, VGG, and then Google Net and RESTnet. Okay, and the number of layers, several layers, 8 layers, 8 layers, 19 layers, and 20 layers, 150 layers. Okay, so each model has many layers, right? So this is the AlexNet architecture. Input is 2227 class 227 class 3, and convolutions you are applying. Okay, there are 96 filters we have applied, and then you have to calculate the parameters. Okay, then max pooling, then convolution, then max pooling, and convolutions. Okay, then we have convolutions again without max pooling, right? Then once again convolution. So you can see 1, 2, 3, 4, 5. Okay, then you are flattening it. Okay, so you are using 5 convolution here, and then after the at the end you are doing max pooling, and then you are flattening it, and you are going to dense layer. Okay, that is fully connected layer. Okay, and then you are trying to get the output. Okay, so like that. Another one is ZFnet. Okay, so there are same process in parallel it is happening. You can see the difference. Totally there are 10 layers, but parameters difference, like that VGC net. So what I am telling you, you please explore the various CNN models, and then you try to apply in real-time applications. Now what I will do, so you learn some CNN model. Now I want to show you how this model is used for real-time analysis. Okay, you will take one use cases, and then since the linear model is used to recognize the digit, I would like to show you in the Altair AI Studio. So there is a tool called Altair AI Studio. Okay, so this tool you can download it. Just go to the website. Just type Altair Studio. Altair AI Studio. And this is a website where you have to go and download the tool. We have free trials, and just go to the resources and downloads. See here. So once if you click there, then it will ask you to sign in. So since you don't have an account, you have to register for the Altair One account. You click register for Altair. So now you see Altair customers, because this tool is available in commercial and open source, and you have to see if you are a faculty, or what you can do, you can click everyone else. If you are a faculty, click faculty, and so you have to give your faculty name, last name, and job title, and I accept the academic end user agreement. So you please kindly do whatever it is asking, and then you register. So once you registered, and you will get a mail for that particular mail, and you go there and you activate it, and then you download the tool and install it. So once you install this tool, how it looks like this. I will show you. AI Studio. Sorry. So this is earlier it is called as Rapid Miner. Now they renamed it as Altair AI Studio. Okay. So Altair company. It's initially when this tool is released, it is a set of forums developed these tools, and then now it is in Altair. Now I think in 2025, the Siemens, I think in the month of April or May, they took over this tool. Okay, maybe very quickly they may change the name of this tool. I don't know. So, but the Siemens has bought this tool. Okay, that is what my understanding. But it is a very good tool. The advantage of this tool is now the trend is no code, low code, right? You don't want to write much code to accomplish any task. So the people who are lacking in coding, whatever deep learning model or machine learning model you can able to develop without coding this tool. That is advantage. Okay. Yes. Are you able to see my tool window? Anyone please confirm it?
Yes, sir. Yes, sir.
So this white space is called as a process area where you used to build the model. Okay. And in the left hand side, you can see in the left hand side and top, it's called as a repository area where you can store some data. Suppose some data you are using frequently, then you can import the data here and you can store it, and whenever it is required, you can use it. And also in the repository area, you can save your once you build the model as a process, you can save it here. Okay, so that is the use of the repository area. And the down, it is a very important area. It's called as operator area, right? So here, what happens? As I said, there is no need of coding. All functionalities are written as operator. You want to read the data, there is operator. You want to write the data, there is an operator. Okay, for example, this data access folder. If you click it, files. I have some files which has some data. I want to read it. For example, I have some data in Excel. Then I can use read Excel. Okay, and then write data. You can also write the data. No, sir, my data are in database. Yes, we can able to read the data from database. And no, sir, I have my data in cloud. Yes, you can store it in Amazon S3 and try to have some login credentials and integrate Altair AI Studio with the Amazon S3, and then you can able to access read data from Amazon or load some data in Amazon, or you write it or you delete it. All these things you can do. No, sir, I have my data in cloud, not cloud, in the Google Drive. Okay, that is also possible. Okay, that is also possible. So you can see here that is applications, then cloud storage. You can are able to see that Google Drive. So you can read data from the Google Drive. That is also possible. So what I'm trying to say that it provides the option to read a data from any places, right? And then the important thing is modeling. So you can, by using this tool, you can develop machine learning model and deep learning model. If you click this modeling, mostly it is used for machine learning. So we can use predictive is nothing but supervised learning. And then you have predictive models, right? And then you have segmentations. Segmentation is the unsupervised learning. Like this you can do. But now you want to implement deep learning. Okay, you want to develop a deep learning model. So what I'm trying to say is that when you download the base model, the base model will not have the features to implement deep learning. Okay, so you have to install the deep learning extensions. How to do that? Please note down. In the menu bar, are able to see the extensions. Click the extensions. Click marketplace. Okay, and here just in the search box you type deep learning. Okay, what you're able to see? You are able to see the deep learning,
Yes, sir.
right? And image handling, ND4J backend. I typed deep learning, but I got 3. So what it means that when you want to experiment a deep learning here, you need all these tools. Okay, because when you say deep learning, we have to process the images, right? So there are two operators, or you can say two extensions. One is image handling, image processing. Image processing, like no, see, you can type here image processing instead of deep learning, right? It is also there, but in image processing, to read a single image, to write an image, you can use it. But for deep learning, you try to install the image handling. So I will type 1 second deep learning. So I have to install this. What you have to, how you have to do? So select deep learning. Now you can see select for update. In my case, I already have that older one. It's asking for update. But in your case, it will show you select for install. So click and then just install these packages. Okay, like that. Select image handling and install it. Okay, and then select ND4J backend and install it. Once you install all the three, you restart it. Okay. So, but in my case, it is already there. I don't want to do that. So you have to install these extensions when you want to develop deep learning models using Altair AI Studio. You got it, right? So when you want to develop your deep learning models in Altair AI Studio, you need deep learning, image handling, and ND4J backend. Okay, so since I have already installed, then where it will be, there will be a folder called extensions. Okay, are you able to see that? I have installed many things. So are you able to see that deep learning here? Yes or no? Are you able to see deep learning here? I hope it is visible to you.
Yes.
Yes, sir.
So you click this deep learning and you can see here layers. Click layers. You can see, are you able to see embedding layer, fully connected layer, output layer, dropout layer, activation layer, batch normalization layer, convolution layer, pooling layer, LSTM layer, recurrent layer. So you can add this layers while designing your models. Okay, this is what you have to do. Okay, layers is there, and there are some readers to read the Keras models. You can read it, and then this is for tensors, text to embedding ID, embedding to text. You can do, and the main thing is modeling. Click this modeling. Are you able to see autoencoder? Autoencoder is advanced deep learning model, and you have normal deep learning network without tensor and deep learning with the tensor. So normally we'll go for deep learning with tensor. Okay, then fine tuning the models. You can, if there are some existing model and you want to fine tune it, you can do that. And you would have heard about transfer learning. What is transfer learning? Any idea about transfer learning? Anyone? Transfer learning?
Sir, your model
Yes.
has already learned and you want, I mean, you train a model and then you can use that model for further training. Already pre-trained model we can use for the custom tasks which we want to do.
Thank you. Thank you very much. So transfer learning means nothing but by using, you have used some data and you train the model. It's called as pre-trained model. And you want to use that pre-trained model for your new data sets. Okay. So that is called as transfer learning. Right. So here by using this import existing model, you can import the existing pre-trained model and then you can make use of it. That is called as import existing model. Right. So these are the different models under the modeling. Now, how to build one deep learning model using Altair AI Studio? That is what you are going to discuss. And before discussing this, what about the data? So you have to download the data. But in my case, I think I have the data. I will show you. Right? I have MNIST data set. MNIST data is nothing but a digit data set. So I have two folder, test folder and train folder, right? You know that in supervised learning, normally you will divide the data into training and testing. So you will divide the data into testing folder and training folder. If you click training, I have 10 classes, that is 0 to 10. So 0 folder has all these 0 digits as the image. There are different set of images to represent 0. And 1, we have 1 images. And then, sorry. And then 2, like that it goes on. All the digits. Okay. See here, 9. 0 to 9. So these are the images we have in training. Under the training, we have 9 different classes. And then you have testing folder. These are the data, combination of all the digits, 0 to 9. You can see 2, 0, 9, 0, 3, 7, like that. Okay, this is the testing data. So try to separate the data as training and testing. You keep it ready. This is the first job you have to do. Then go to your modeling, how to do that. In my case, see, as I said, there are some operators. Which is required. So what do you want to do now? You have to read the image. What kind of data you are going to handle now? Since we are going to discuss CNN, the data is image. How to read this image? How to read that? Okay. So you just click extensions. And you can see image handling. Are you able to see image handling? Under the image handling, read. Are you able to see read image metadata?
Yes, sir.
Okay. So what is the use of this read image metadata? You know that deep learning, where you need a lot of images, right? You have to read a lot of images to train the model. Now you just send read image metadata, go to the directory and locate your data. Right? So click train and then open. Simple. And then you run the process. What you are able to see, that complete training data is loaded here. Okay. All the data has got loaded here. See, you can have run some 600 images we have. Okay. Then once it is data is loaded, what you can do? When see there are different type of data, right? You have numerical data, you have text data, you have image data. When it is numerical data, you have to do some data pre-processing, like missing value analysis and removing noisy. And then the important data pre-processing is called as data standardization. Did you heard about data standardization? Like normalization. Okay, if you have numerical data, you try to convert all the attributes into same scale. That is called as data standardization. And then if you go for text data, like you have tokenization, stemming, stop word removal, and so on. Like that, if you are reading the images, okay, then you can you have to do some data pre-processing methods. You have some data pre-processing methods like scaling the images and applying some segmentation technique. All these things comes under the data pre-processing the images. So you just type pre-processing. Are able to see pre-process images. Okay. Pre-process images. Then you just apply pre-process images. And are able to see that it is something different? Yes, this is a double line operator. It means that it is a nested operator. It means it has some more functionality in it. So here you can do, if you are able to do some pre-processing techniques, you can add. Otherwise, just you connect this. Okay, for example, sometimes people will apply rescaling, rescale. Image rescale. It's not there. Sorry, resize the image. Not rescale. Resize the image. What is the size? You want to say it is 100. Let me say I want to have some 50-50. I can do that. I want to convert all the images into same size. Right. And then you connect it. Then go back. Okay. So like this, you can do that. Okay. So what is the path you have to give? Just give the path and then so that it will be rescaled. Okay. And now this is the way to read the images. Then later on, what you can do? You can apply your deep learning model, right? So go here and type deep learning. deep learning tensor you choose. Okay. And then this is the deep learning model where you can add, you can develop your own deep learning model, how many convolution layer you want. Then you go there and here, if you want to add a convolution layer, you add it. Okay. And then you want to add pooling layer, you add the pooling layer. Right. Then you want to have some more convolution layer, yes, you can do that. Okay. Like I've shown you, right? Then I want to again add the pooling layers. Right. Then I want to have fully connected layers, right? Finally, we'll flatten it and then we'll have fully connected layers, right? So we can supply this. For the output layer, the connected layers. Okay. So like this we can do. Okay. So now what I will do, I will just open the existing model because time is not there. I will open the process and then I will show you. 1 minute. So just I'm loading the data which you want to use. Just click data set, MNS data set. Then I want to load the train data. Okay. So actually, there is no operator called training images. I given name like this, but you can see the operator is read image metadata, and then I given my training data. Then, as I said, you have the pre-processing image operator, and you want to pre-process it. Here I have added the resize image. Okay. Then I used the deep learning TensorFlow, and if you click that, it is a nested operator. If any operator is with the double line, it is a nested operator. Okay. So here you can see I have added one convolution layer, and then so I have to connect this input, right? Then I have added a pooling layer. Then I use dropout layer. What is the use of dropout layer? You are seeing that some connections you don't want, you don't drop out. So you can add dropout layer. Then I use the fully connected layer, then the output layer. Okay, then I connected this. So here only it is your job to build your own CNN model, custom CNN model. Okay, by changing the layer hierarchies. Okay, even see, I used only one convolution layer, but what you can do after this pooling layer, you can have one more convolution and then pooling, then you can try. The results slightly may change. Okay, so like this you can do it. So where you are trying to do this, you are trying to do inside this deep learning TensorFlow. Okay, then we will get the model. Okay, so the model got developed, right? Then it will be there in the model. So you take the model, and then you would have lost because of this pooling and all. You would have lost some informations, but so you won't have skip connections. They used to say in the CNN model. So you won't have some more information, the original information from the image. So that's why you are taking one input from the pre-processing images, and then there is operator called the generic. Okay, like which is mainly used to group these models, group this model with the features. Then now the model is ready. You want to apply this model on the testing images. So what is happening in supervised learning? There will be training data. You will apply the algorithm and you will build the model. Then once the model is built, you will apply this model on the testing data. Okay. So you will know. You will apply. This is called apply model. If you surf here, there is operator called apply model. Apply model. Okay, so you can apply this, and this is the another once again like read image metadata, right? You have to read the testing data, right? So like here I've shown MNSAT, you have to load this testing data. So you just load the testing data and then you apply this model and then you will get the label you want upon it. Okay, so this is nothing but why it is append. This operator builds. You can see what is the use of this in the right hand side. You can see the help. This operator builds merge example set from 2 or more compatible example sets. by adding all exams into a combined set. That is the main use of append. Okay. Then so here you used to say it is a memory optimized or speed optimized or auto. And then finally you want to see the performance of the model. So you know that there are many measures like accuracy, recall, and so on. You can see the accuracy is by default is enabled, and there are other parameters like recall, error, and precision, and all these things you can enable it. Okay, then you can, I think you can run this model. Let us see what is happening. So this is how you can use this tool to develop deep learning model. So I have explored only CNN, but you can explore the RNN maybe after some time. If you get another opportunities, then I'm able to give talk on RNN models like using LSTM and actually we have used the LSTM for remote sensing, like particularly whenever you deal with the prediction, predicting the time series data. You can do like we have done one project called change reduction. In change reduction, you, for example, you want to know, because in the urban development now we know that many places are not developing, and the urban managements or urban development, so they want to know what are the changes will happen in the futures, right? So I want to predict what will be the changes in Chennai in 2035. Right. So for that, what I will do, I will use the previous years of data, like past 20 years of Chennai data. And then if I give that input, okay, to my LSTM model, then what you can do, you can able to predict how it will be in 2035. That is possible. So it's called as change reduction. Change reduction is nothing but what are the changes which are happened from the by using two images, like old image and today image. Two images will be taken for a particular location, and then you will see what are the changes happened the particular year. Okay, that is called as change reduction. So that is also we have done. Like that, there are many applications we have used deep learning, like UCNN for our projects. Okay, and RNN also, like LSTM we used BERT model. Okay, there are many things you did for real-time applications. So what I am requesting you, all of you, I don't know, maybe there are some faculties, and there are some research scholars who are doing the research. Yeah, there are many tools. I am exploring only one tool here, and there are a lot of tools are available in the market, and you can make use of it. Normally, people used to develop models by using Python. We can do that, but if you're struggling in coding, this kind of tool will help you to develop your models. Okay, that is the ultimate aim, because there may be some people from other background without CSC, then for them it will be difficult. So what you can do, you can make use of this tool. So this tool can be integrated with the Python. That is also possible, and you can integrate Python, like how I added deep learning extensions. A similar way, you have to go to the extensions and marketplace, and you try to find Python. You just type Python, you will get Python scripting. You are able to see that Python scripting. It's get running. That's why I'm explaining the other component, because it's running here in the background. Slowly it's running. I don't know whether the internet is. It takes time to read. So the Python scripting can be added. So what are the steps you have to do? First, install the Python in your local system and install Altair Studio. And then while installing Python, please note down the exe path of the Python. And then once you install Altair Studio, please go and add this Python scripting, like you install it here. Since it is installed already, in my case, it's not showing. Otherwise, in my case, it will be showing select Python scripting. select it and then install it. Okay. So once it is done, once Python scripting is done, then you got to go to settings and then you have to click the preferences, and you can able to see Python scripting. Once you add that Python scripting extension, then only you can able to see that. Click here and go there, and whatever I told no, while installing Python, you have to note the exe path. That exe path you can supply as input here, and then you click test. So that it means that you are trying to establish the integration between Python and Altair Studio. If you get the green tick mark. Okay, yes, it is done. Then what you can do, you can go here and there is an operator called execute Python. It's taking too much time. Execute Python, I can see here. Okay, then you can add this here, and now you can see you would have written already the sum, for example, like Navy Bayesian classification you written in Python, and you want to execute here. Yes, you can do that. You read the data by using Altair Studio component and connect the data as input here. You write the coding on your own. How to do that? You would have written already script, okay, that you can call here, or go here and then this is a place where you can type all your Python scripting. Okay, then apply and then run. That is the way to use execute Python. Because what I'm saying that since this Altair Studio is no code, low code, if you suppose you are a PhD student and you want to develop your own model, then you will not be able to do it. Okay. So what you can do that you want to write something new, you can use Python. That's what I'm trying to say. Okay. Right. So we can use Python and we can integrate R. Even you can able to integrate generative AI models here. There are many facilities there. You explore it. It is all up to you how you are going to explore the tools. Okay. So my request to everyone is you have to upgrade our skills, because you are a computer science people and you want to sustain in this field, like whether you are a faculty or a student, and if you want to differentiate from your friends, yes, you should have some add-on skills. Okay, so learn something new always. Like now we are moving to quantum era, so focus on quantum computing, quantum AI. Okay, and yeah, this is a way you have to develop your skills. Still, it is only 30%. I don't know how much time it takes. Let us see. Okay, let it come. In the meantime, if you have any queries, let me know, so that once it gets, then I will show you the output.
Sir, I am Ketan Jetale from Maharashtra. Sir, I have a question that which is the best tool to use the deep learning model to create deep learning model? Like I have my topic is skin disease detection, skin disease detection using CNN. So that's why I have to create a model. Sir, which
yes,
is
we
the
can
best
do that.
tool?
It's a good question. Yeah, 1 minute. I'll show you. I'll give you a surprise for you. Wait. You said skin, right? Skin disease.
Yes, sir.
I think you already have model for skin disease. I have actually developed a model for skin, and you have the skin cancer data set, and the same tool you can use, sir. Like how I said, no. Okay. Where I kept the data set, it is there. I have skin cancer data set somewhere I used to. That is a problem with me. I used to forget where. Okay. So the same way, sir, how I have shown, like here you have the skin cancer. Now, like you take the data set, you may have how many classes it will be there? Skin diseases, or you are going to have only skin cancers?
Sir, only skin disease. Like
How
some
many
disease.
type? How many diseases?
like psoriasis, etc. Means basic skin disease, sir.
No, no. What I want to say. So let us have some 5 diseases.
Yes, sir, yes, sir, yes, sir.
So what you have to do? You have to create a folder like this, sir. We have, see, for example, I have shown here for you the MNSD data set. The similar way. See what you do like this. See what I did MNSD. I have train and test. No, you create a folder train. Okay.
Okay, sir. Okay, sir. Okay,
Here,
sir.
if you have 5 diseases, sir, if you have 5 diseases, then you
Okay.
have one folder for disease 1, where you keep the disease 1 images. Then
Yes,
there is
yes, yes,
second
sir.
folder, you try to have disease 2 images. Then third folder, disease 3 images. Like that you can have. If you have 5, you can have 5 folders.
Okay, sir. Okay,
Then
sir.
in the
Understood.
testing data, you can have all the images. So similar way, what I have did here, the same model you can use, and you can try to classify the different type of skin diseases using deep learning, sir.
Okay, sir. Okay, sir. Sir,
Okay,
understood.
Kevin.
Thank you, sir. Yes, sir. Thank you so much.
Yeah. Anybody else? Any other questions? Anything is there in the text prompt?
So I have a doubt. Actually, my research area is large language model. So
LLM, yes.
how can this be this AI tool be used for that purpose, sir?
Yes, good. So you go to the extensions and marketplace, just type. Are able to see generative AI models? Large,
Yes, sir.
are able to see that generative model extension
Yes,
offer
sir.
access to large language models, right?
Okay.
So you can use this component, madam. You can install this, okay?
Okay.
And then you can take some foundation model from Hugging Face, and then if you want to fine tune it, okay, you can do that.
Okay.
Okay, so once if you install this, what will happen? I will show you here. See, if you click the extensions, are you able to see generative models?
Yes, sir.
Are you able to see here models? Open AI. Okay, so you can fine tune the models. You can do many things, madam. To try.
Okay. Okay, sir. Okay, sir.
And there is a separate model for NLP also. Okay.
Oh, okay, sir.
Apart from this, you have a separate model for NLP that also you can try. Core NLP. See. So you try this.
Okay, sir. Thank you. Thank you.
Thank you, madam. Any other questions?
Sir, actually, okay, sir. My research area is regarding the human action recognition, sir. Can we apply
Yes,
this
yes.
one in action recognition? So here I'm using 3 models, RGB, depth, and skeleton. Can we apply this in my research, sir?
Yeah, you can apply. See, only thing is you have to transform your input. What kind of input? If I know, then I will help you. Yes, like no, you said whether it be images or actions or what it is. What kind of data?
Sir, action recognition, sir. What's the we
Oh,
need
that's
to
what kind of input it will be. Your action recognition will be images
we are
or it will be signals.
images,
Yeah.
depth, RGB, images, depth, and skeletons. 3 types of models
Yes,
are.
yes. We can do that, madam. You try. Let me know if you have any difficulties.
Okay.
But you have to transform your data into the required format, and then you have to apply the algorithm. Always see when you do this AI models, you have to transform. You cannot apply the AI models on the raw data. You have to
Okay.
convert in some form, okay, which is suitable
Okay.
for your algorithms. So once
Okay.
if you convert your data into that form, then it is possible to apply, madam. Yes, you can use this
Okay,
tool.
sir.
Try.
Okay.
Let me
Okay,
know
sir.
your exact input, then I can able to tell you. Yes.
Okay.
Yeah. Any other queries?
So I have one more doubt.
Yes.
So actually, we are using this AI tools, right? Especially for if research purpose, if you're using this AI tools, there's a present norm that your research area should only take 20% of AI tools.
Mm.
So how
No,
can we?
that is the case of like you are writing now, generative is writing paper. And right. So many people are using this ChatGPT, or there are some tools like Genie AI, and there are many tools are there available in the market, and they are using that and then they're generating the content. Okay, so that's what now there is going to be restriction even very soon. The UGC is going to announce in India also. Okay, people should not use much AI informations. Okay, generate information for the research. Like already many top conferences and publication paper, the journals, they are detecting. If you are submitting a paper, there are tools which detects whether the content is created by AI. Like you take Turnitin. Turnitin is a good software to check the plagiarism. In that, there is a now new feature is added which detects whether the content is created by AI or not. So if it is detected that if they found that it is generated by the AI, right away they will reject your paper. Okay. So I am telling you, don't use this tool to write the paper. But if you want to produce some outputs, yes, you can use it.
Okay. Okay, sir. Thank you.
Okay. Okay, so it's taking time. So what will be the output? No, the output will be what image it is. It will say that the testing data, if it is a like no, for example here, in the testing data, it is 2-digit. Right? The first is a 2-digit. Then your model, if it is correctly classified, it will say that it is a 2, image 2. 2, okay, and sometimes if it is wrong classified, it will say it is 1. So that will be the output actually. So it's a classification. These are the images which are there in the testing data, and now if you run this model, the model is whether able to classify these images correctly or not. That is what the output is. You can try later and let me know if you have any doubt. I will share you my contact, and always you can write a mail to me, and I will give you one more mail ID. Please, you can note down. So whenever I find a time, I will, yeah. So better to, instead of first mail, it is official mail, and the second mail is a personal mail. You try to give a mail to the second one, so that will be easy. And this is my number. Okay. So if you have any doubt, and for the deep learning, there are good books. This is a book like Deep Learning by Ian Goodfellow. Please refer this book. You can able to understand. And these are some learning resources like please follow this. There is a course by from IIT Madras, and if you look the NPTL, Mitesh Kapra is a associate professor in IIT Madras, and recently he has been shortlisted as a top AI scientist, 100 AI scientist. And his lectures are very good in deep learning. Like even I have shown some conclusion I have taken from his slide only. Okay, so please go through that, and if you look the NPTL now, the same IIT Madras content also referred by IIT Roper. So you can say IIT Madras and IIT Roper. So this course is very good. And then there is another course on deep learning by IIT Kharagpur. You can just explore it. And there is another course on deep learning by IIT Patna. And there is a course on deep learning for computer visions from Stanford. Okay, so this links which gives the how deep learning is used for computer vision. And then from MIT, there is a website called deeplearning.mit.edu, and you can always refer this. So these are some of the learning resources. I hope it will be very useful for you, and make use of it. Deep learning is very important. So study well, because it's a very huge one. It cannot be covered in one day. Like just I took only 2.5 hours or 3 hours. So it's a bit hectic to cover it. You need a series of lectures like this, and we can able to cover each topic, right? So I request all of you to make use this kind of workshop, so that you can gain your knowledge. So you have to always upgrade a skill. There is no other. Okay. So if you don't have any other questions, then I would like to wind up my sessions. All the best. Do well. Thank you. Thanks for the opportunity. Madam is always inviting me, whether it is a BOAS or a workshop. It's a long-term relationship. when I was there in VAT, I came to the college, and then I given talk, and then keep on. Madam used to invite me for the different scenarios. So thank you, madam, for this opportunity, and thank you all the organizers who contributed for this ATAL FDP. Thank you. All the best.
Thank you, sir, for this highly informative session. Your insights and perspectives have deepened our understanding of deep learning architectures. Now, before we conclude, I kindly request at least 3 participants to share your feedback on today's sessions. While sharing your feedback, kindly switch on your camera.
Good evening, all. On the 4th day of FDP, we had 2 sessions handled by our resource person, Dr. Venkatesan sir. I feel the sessions were highly informative, interactive, as well as interesting, sir. In the first
Thank you.
session, was on introduction to deep learning, the theoretical foundation and core concept. It provided a clear understanding of fundamentals of deep learning, foundations of neural networks, the backpropagation, and the chain rule, etc. It was explained in a systematic way. After that, the second session, the modern deep learning architecture, CNN, RNN, and transformer. It was a detailed session handled by the resource person. He covered the CNN architecture, the parameters, pooling, match pooling, type of pooling, different types of CNN architectures, such as LXNet, ImageNet, etc. And finally, a detailed session on AI tools, Alter AI Studio. It was really a wonderful session as a researcher as well as an academician. Overall, both sessions were really valuable as both as academician as well as the researcher, sir. On behalf of all the participants, I sincerely express my sincere thanks, sir, to Dr. Venkatesan sir for delivering such a insightful session. I also thank to the coordinator, Ms. Bersimis, and all the teachers of organizing teachers of St. Mary's College, Thrissur, for organizing such an insightful FDP, and also thank all the participants for active and enriching participation. Once again,
You are from which college?
Okay, I'm from Government College, Kasaragod, sir. Government College,
Kasaragod, very good.
Kerala district, Kerala.
Yeah, I know because I worked in Mangalore, so I know that. Yes.
Oh, very good. Thanks. Okay, sir. Thank you.
Thank you.
So
Thanks
much.
for your feedback. Yes.
Good evening, sir. I am
Good
so
evening, sir.
happy to. I'm so happy to tell that I was really able to bridge the theory and practice between this data science and deep learning on this 4th day of this ATAL online FDP. Venkatesan sir, Associate Professor of NIT Puducherry, was able to describe the details from introduction part of data science to deep learning areas, modern, and in the second part, as the topic mentions, modern deep learning architecture with the help of Alpha tool highlighted. So even though at the initial time, sir was very busy with traveling, he was able to take the classes in a very interactive sessions without any presentations, then explained and interacted with the audience with the basic feature engineering and differentiated machine learning and deep learning at the initial stage. Then thank you for introducing this max pooling, then sharing the importance of CNN for vision, speech recognition, and the relationship between the input parameters and output parameters, lineage. All the tools were very helpful. All the topics motivated us to learn the new developments, highly informative, and in a very interactive way you presented. Thank you, sir, very much. Thank you once again for all the coordinators
Thank
for
you, sir.
organizing this event. Thank you.
Sir, which college you belongs to? Prasad, sir. Prasad Joseph, sir.
I belong I belong to Federal Institute of Science and Technology, Angamali, FISAT.
Okay, sir. Thank you. Thank you, sir.
Welcome, sir.
Good evening, sir. I am Daya Naik
Yeah.
from
Good evening.
Mangalore, sir, from Srinivas Institute of Technology. And I would really thank you for insightful session on both deep learning, starting from fundamentals to the modern architectures of CNN. It was really explained in a nice way. Anybody who did not have any basics also were able to understand the things. And the introduction to the new AI tool also was very helpful for us. It will be really helpful to use it in the area of research as well as teaching new things to students. And we really thank the organizing college and the Department of Computer Science, St. Mary's College. And also we thank Dr. Venkatesan sir for sharing his insightful knowledge on the topics. Thank you so much. It was really informative and a great
Thank you, madam.
session, sir. Thank you, sir.
Thank you. Thank you.
Thank you all for your valuable feedback. Dear participants, we kindly request you to switch on your cameras for a group photograph.
People will be in different places and so, yeah.
Thank you, dear participants. With this, we conclude day 4 of FDP. It has been a day of great learning filled with rich insights into the foundations and modern architectures of deep learning. We sincerely thank all the participants for their active involvement and look forward to your continued participation in the upcoming sessions. Have a peaceful night. Thank you.
Thank you, madam. Thank you. Thank you all. Bye.
Thank you.